Okay, so before I reveal the title of our notes, I want to give you a problem and see what you think we could do about it. So I've got a system of equations, 5x plus 6y equals negative 8. And I have 2x plus 3y equals negative 5. And we've already talked about how graphing is not the best way to solve a system because we can't always be super accurate. You guys could just, even seeing on your own graphing that you can be slightly off. Just doing one equation, so doing two at the same time and finding where they cross can be hard. None of these variables come without a coefficient, so doing substitution is going to be messy, lots of fractions, probably not a good idea. But this also doesn't meet the criteria of elimination because I don't have same variable with same coefficient with opposite signs or with the same sign. I don't have any of that. So what do you think I could try to do in order to solve this particular system? There's got to be something more to try. Lainey, what do you think?
Since 3 goes into 6, you could maybe try and divide, to make them. So you could divide the top equation by 2, or just by 2.
Okay. I like that idea of dividing the top equation by 2 in order to get my coefficients to match. The only problem is now you're creating fractions, okay? Because then I have 5 halves x, I have plus 3y equals negative 4. So I still now have a fraction to contend with. So that could work, but I love the fact that you notice that 3 and 6 are related to each other, okay? Alan, I saw your hand next. Okay, so what I could do is alter one of the equations, and instead of doing division where I'm going to create fractions, I could do multiplication where the fractions aren't going to show up. Now, he says multiply by 2. Okay, good, because I was going to say that gives me the good situation with the same variable, same coefficient, same sign. That's good, but what's best is to have the opposite sign. So what we're going to do is alter the equation with the smaller variable, and we're going to multiply it by negative 2. It's now going to become negative 4x minus 6y equals 2 negatives make it positive 10. Our other equation, which was the 5x plus 6y equals negative 8, and now we're ready to solve the system. We have the best case scenario that when I add signs are different. Bigger number's positive. 5 take away 4 is 1. I get x. My opposites and my y's eliminate. Positive 10 take away 8 is 2. Okay? And now I'm just going to take this answer 2 and I'm going to substitute it back into either original equation and solve for y. So I chose this equation because the numbers are smaller. So I have 2 times the x value of 2 plus 3y equals negative 5. So I have 4 plus 3y equals negative 5. So I'm going to subtract 4 from both sides. I get 3y equals negative 9. Divide both sides by 3, and I get y equals negative thirds. So my answer appears to be 2, negative 3. Now I can always do a check. So is 5 times 2 plus 6 times negative 3 actually equal to negative 8? So I have 10 take away 18, and that's going to give me negative 8 equals negative 8. So it satisfied the top equation. Let's try the second one. 2 times 2 plus 3 times negative 3, does that equal negative 5? So I have 4 take away 9. Equals negative 5. The signs are different, so I'm going to subtract bigger numbers negative, and I get negative 5 equals negative 5. So it satisfied both of them, telling me that, yep, that's the answer. So what is going to be this technique's name? It's just using multiplication with elimination. Okay, so we are going to have to do some prep work to get this done. So we're on lesson 6.4, elimination using multiplication. And again, not saying Lainey's idea wasn't a good one. It just, if we can avoid creating fractions, we're going to do it. And then also keeping in mind what sign do I need in order to have opposites. So use that also at the same time.
If they could all be divisible, could you still use division?
You could use division if you had all the numbers could be divided by that value. Yes, absolutely, and sometimes that will work as well, okay? So we are at 222, right? Yes, we are. Okay? Okay, so that's the best case scenario. So let's talk about this in words a little bit. So best case. You're going to multiply one equation by a value that creates same variable, same coefficient, opposite signs. Signs, not sides. Okay? And then once we do that, we then add the equations and solve. So that's our best case. What do you think our worst case is going to be? And I do say worst case because, and I shouldn't even call this the best case. This is the best of the bad, really, because this is the one that requires the most. So what do you think is going to be even worse than what we just had to do? Bryce? Yeah, what if we weren't lucky and one coefficient didn't go in evenly into the other coefficient of the same variable? Now we're going to have to multiply both equations by something to create a match. Okay? Fractions, it's actually not worst case scenario. It's just you're afeared of them. Okay? You just get rid of them. Okay? So worst case, you're going to multiply both equations by multiply both equations by some value so that it creates same variable, same coefficient, opposite signs. Now, when I say by some value, it's not necessarily the same value for both equations. That's not going to cut it. So I'm going to have to be thoughtful. What am I going to multiply this top equation by? What do I need to multiply the bottom equation by so I can get a match? So then it becomes complete choice. Do I want to eliminate my x's? Do I want to eliminate my y's? Okay. Once we do that, then we're going to add the equations and solve. Okay, so as we kind of go through this, I'll talk about clues as to what I would be multiplying by and why I would choose to multiply by that. Okay. Brandon says yes, we move on. All right, so let's just kind of solve some problems. Let's do another one kind of like that now that we just got our feet a little bit wet, and the directions are going to say use elimination to solve the system. Oh, use. So that means if you think you could solve the system a different way, you're not allowed to on your homework tonight. When it comes time to taking a quiz or test and it just says solve the system any way you choose any way you want. Okay? If it specifically says on the quiz or test, you must solve this using elimination. Elimination means you could just add the equations together if you meet the condition of same variable, same coefficient, opposite signs. You could multiply by -1 to force that to happen. Or elimination could mean you need to multiply one or both equations by some value or values in order to get a match to eliminate. All right, so let's start with this one. We have 9r plus q. There we go again. Equals 13. 3r plus 2q equals -4. So here's Brandon at Modern Day next year, and he sees an R in equation, and he's going to sit there going, arr, arr, and his classmates and his teacher are going to look at him like, oh, dear Lord, what? Oh, yeah, I see that happening. All right, so do we have the ultimate best scenario that we have a match? So we don't have that. So we're going to have to figure out. So we actually have choice. Could I get my R's to match? I could. What would I do to make my R's match? Multiply the bottom by -3. How could I get my Q's to match?
Yeah, that make it bigger.
Multiply the top by -2. So the option is, which way do you want to go? Because both will work.
Smaller number. Bottom.
Oh, so you want to multiply the R in the bottom equation by -3. Okay, all right. I'm going to make you walk the plank pretty soon, mister. So I'm going to multiply, and honestly, this is the better strategy to show that you're going to multiply, because you need to make sure you remind yourself every term is going to get multiplied. So this becomes -9R minus 6Q equals 12. And then we're going to bring down that top equation. It's easier to do the math when they are side by side. And I liked how you guys said this is the better way to do this because the numbers are going to be smaller. Because you're right, if I multiply the top equation by -2, now I have 2 double-digit numbers. Okay? So when I add my R's, eliminate, and then I'm left with -5Q, -6 plus 1 is -5, equals 25. Divide both sides by -5, and we get Q equals -5. Okay, now we need to figure out what the R value is. So it really doesn't matter which equation we go into. I'm going to go to the top one. So 3R plus 2 times -5 equals -4. So 3R minus 10 equals -4. I'm going to add 10 to both sides. And I get 3R equals +6. Divide by 3, R equals 2. Now, have you guys noticed the increase of the amount of work we have to do with systems once we hit elimination? When we were doing graphing, there was very little work to do. Just set up your equations, identify your slope and y-intercept, and go for it. When it was substitution, it was just replacing a variable with an expression and then solving it. Now this one, the math gets longer. Okay? So, how do I put these together? Okay? Okay? So our alphabet, and this is when it gets a little bit interesting that I do have people start singing their alphabet because they don't remember which one comes ahead. Okay, so adorable. So we go alpha order. Okay, now I would recommend that you double check. So I'm going to do a check real quickly. I did.
Q R S T U V W X Y and Z. Now I know my ABCs.
Okay, here's what's beautiful. Here's what's beautiful. This is recorded. This is going up on YouTube. And strangers watch these videos. Oh, yes, they do. I have subscribers that aren't in my school. So you do. Thank you. No, honestly, the book read it the other way. Isn't that funny? Yeah.
Oh, they messed up. They're not pirates.
Yeah, well, they probably don't know their alphabet either. Let's do the check. But that was actually pretty priceless. Thank you. So 9 times -5 plus 2, does that equal 13? So here, look at this. Here's our check. Does -43 equal 13?
No.
Oh.
What is this madness?
So what if we solved that and did it the different way?
What?
So our idea of always alpha order did not work here on this particular problem. Hence the reason why it's very important to check when it's not X's and Y's. So, and then we can check the other one now, putting them in this order. So this didn't work. And then we've got 3 times the R value of 2 plus 2 times the value of -5. Does that equal -4? And 6 take away 10. So interestingly enough, it didn't go alpha order this time. Now, I think these are somewhat a little bit on the unfair side, so I will go ahead and use X's and Y's when we go through these types of problems so that we don't have these kinds of confusions. However, you cannot be blind and just follow one idea. You do need to test, and that is a prime example of when you don't check how you could have the right work but get the wrong answer. All right, whoa, we got to do another one. I'll listen to you, whiners. You just want to sing some more, I know.
As long as it has R in it.
I'm just gonna watch that video just to listen to us.
Miss Roseman, just a question. Can I bring a parrot to school and a pirate costume one day?
Parrot, no. Pirate costume, just have at. Okay.
I'll be a black
So,
Jedi.
this is what we call the worst case scenario. Nothing matches. Nothing is a multiple of the other thing. So this is where I'm going to have to multiply both equations by something in order to get a match. And it really, in this one, the numbers are fairly close. So if I had to make a choice, 2 and 3 are slightly smaller than 3 and 4. So I would probably try to eliminate the y's. In order to eliminate the y's, what would I need to multiply the top equation by? Okay, so I'm going to multiply by 3 everything on top. This is going to give me 12x plus 6y equals 24. All right, what am I going to multiply the bottom by?
-2.
Okay, not -4, that won't match up my y's.
4.
And,
I was -2.
well, you can't do the other one. We already made this commitment. So we get -6x minus 6y equals -18. Now, notice what you guys ended up multiplying by. Because these numbers are prime, there's no common multiple of them, or the first common multiple is their product. So what I ended up doing is multiplying the top equation by the coefficient, or multiplying the top equation by the coefficient of the bottom, and I ended up multiplying the bottom equation by the coefficient from the bottom. So that tends to be how we end up solving this problem. So now we've created the best case scenario, and we can add. So we get 6x, my y's eliminate, equals 6, divide by 6, and we get x equals 1. So now I'm going to go back to an original equation, though, and figure out the y value. So I'm going to go here, doesn't matter, 4 times the x value, 1, plus 2y equals 8. So 4 plus 2y equals 8. Subtract 4 from both sides, and we get 2y equals 4. Divide by 2, and we get y equals 2. So my ordered pair is 1, 2. What I want to make sure I do is to check my work. So 4 times 1 plus 2 times 2, we want to know if that equals 8. So I get 4 plus 4, which gives me 8, and 8 equals 8. So it satisfies the top equation. Second equation, 3 times 1 plus 3 times 2 equals 9. So we get 3 plus 6, which equals 9, and 9 equals 9. So it satisfies the bottom equation. So that's what you guys are going to be working on tonight. All right?